Hi everyone. So let's solve this question. The saponification number of a fat or oil is defined as the number of milligrams of KOH required to saponify 1 gram of fat or oil. To a sample of butter weighing 2 gram is added a 25 ml 0.5 N KOH solution. After saponification is complete, 8 ml of 0.5 N HCl is found to be required to neutralize the excess alkali. What is the saponification number of butter, right? To solve this question, let's revise some concept which we are going to use while solving this question, right? And I'm sure you have studied about all this concept while studying the chapter equivalent concept. So let's start revising those concepts. The first is how to calculate number of equivalent. So number of equivalent is basically given mass upon equivalent mass. And how to calculate equivalent mass? It's basically molar mass upon n factor. So let's take few examples, like suppose let's take KOH. So for KOH, it's a base, and for base n factor is number of replaceable OH minus. So here the n factor is 1. Molar mass for KOH is 39 plus 16 plus 1, that is nothing but 56 gram. And equivalent mass, that is molar mass upon n factor, that will be 56 upon 1, that is again 56 gram. Okay. Now let's talk about HCl. HCl is an acid, and for an acid, the n factor is basically number of replaceable H plus in a reaction, right? So for HCl, the n factor is again 1. Molar mass is 35.5 plus 1, that is 36.5 gram. And the equivalent mass will remain same as molar mass because the n factor is again what? 1. So this is what the equivalent mass of KOH, that is 56 gram, and the equivalent mass of HCl, that is 36.5 gram, right? Okay. Now, let's go and revise this term, that is normality. So what is normality? Normality is basically number of equivalent for solute divided by volume of solution, and that volume of solution you have to take in what? Liter. The alternate way is, instead of equivalent, if you take milli-equivalent, you can also take volume of solution in ml. You will get the same value. That is what normality. So to calculate normality, number of, instead of equivalent, we are taking milli-equivalent of solute, but we are dividing volume of solution here in ml, right? That will give you normality. For that, the symbol is N, right? One thing which you should see here, right? What if we we multiply normality with the volume of solution in ml? In that case, we will get number of milli-equivalent of solute, right? So this is one important point which we are going to use, right, while solving that question. Now, so that means normality into volume of solution in ml will give you milli-equivalent. And if you use this particular formula, if you multiply that number of milli-equivalent to equivalent mass, you will get the mass of that particular solute in milligram, because you are using basically what? Milli-equivalent, right? Okay, so that's about normality and number of milli-equivalent, and from that number of milli-equivalent, how to calculate the mass of a particular solute, right? Fine. Now let's go back to another concept which we are going to use, that is law of chemical equivalence. To understand this law, let's take an example. A reacts with, or let's take A plus 3B, giving you 2C plus 4D, right? So A reacts with B and producing what? C and D, right? So what law of chemical equivalence says? Law of chemical equivalence says one equivalent of A will react with one equivalent of B, and it will produce one equivalent of C and one equivalent of D, irrespective of their stoichiometric coefficient. So that's the beauty of equivalent concept. When you're using equivalent concept to solve a particular question, you don't need to write a balanced chemical equation, right? So to understand this, if we have one equivalent of A and if we have two equivalent of B, right? What will happen? And suppose there's no C and D in the container, right? So reaction is just starting. What will happen? One equivalent of A will react with one equivalent of B, irrespective of their stoichiometric coefficient. So A will remain, it will get totally consumed, right? And B will be one equivalent remained. And how much C will form? Again, one equivalent. And how much D will form? Again, one equivalent, right? So this will be the final composition, right? After the reaction, right? Where A got consumed completely because it was acting as a limiting reagent. You can see, you know, why I took, this one equivalent of A and two equivalent of B, just to show that, okay, A is here getting consumed and it has nothing to do with the stoichiometric coefficient. Instead of A, now if we take mole, right? A plus 3B, now we have 1 mole and you have 2 mole of B, right? And in that case, if you have to see how much C and D will form, right? In that case, you see, here B will act as a limiting reagent, right? Because 2 mole of, for 3 mole of B, 1 mole of A is required. So for 2 mole of B, definitely less than 1 mole of A will be required. So here B will completely consumed. So that is the difference you see here, right? Using equivalent concept, we don't need a balanced chemical reaction, right? And law of chemical equivalence says that one equivalent of reactant will react with another one equivalent of another reactant to produce one equivalent of products, right? Fine. One last thing before going to solve that question. What is this fat or oil? So they are basically triglyceride, and triglycerides are nothing but ester that is derived from glycerol and fatty acid, right? So what is this fat or oil, or we say triglyceride? So this is CH2O, C double bond O R, then CHO, C double bond O R, then CH2O, and then here C double bond O R. This R is basically an alkyl group that may be same or different, right? Okay. So this is basically what your triglyceride. And this triglyceride is nothing but ester that is derived from glycerol and 3 mole of fatty acid. So for each mole of triglyceride, we need glycerol and 3 mole of fatty acid. Actually, this fatty acid is responsible for the reaction of fat or oil with what? NaOH or KOH, right? So it will react with KOH and it will form glycerol. This is what glycerol, and it will form potassium salt of fatty acid. potassium salt of fatty acid. Of course, in case if you are using NaOH as a base here, the reaction will be same. The only thing is what? The product will be, that will, in that case, sodium salt of fatty acid will form, right? So this is what the prerequisite. I hope you have understood all these concepts, right? Now let's get back to that question. So first, we will concentrate on this part and then we will go to the first line, right, at the end. So what it says, we have 2 grams of butter. And of course, when we will find saponification reaction in laboratory, right, we will put some solvent like ethanol or ether, right? So here you have, 2 grams of butter. Okay. And what you're doing, you are adding 25 ml of 0.5 NaOH solution. Okay. So let's first calculate. We have normality of KOH solution. We have the volume. So first calculate the number of milliequivalent of KOH by using that formula. We know that normality into volume in ml will give you volume of solution in ml will give you basically what the number of milliequivalent of solute, which is here KOH, right? It's KOH solution. So it will be 25 into 0.5 and milliequivalent. So that will give you 12.5 milliequivalent, right? So we have 12.5 milliequivalent of KOH. So what's happening? You see, you have basically butter. That butter is reacting with KOH, and we are going to use law of chemical equivalence. So we are not at all concerned about the stoichiometric coefficient of this particular reaction, right? Some product will form. We have already seen that product, right? This is basically nothing but saponification reaction, right? So you have 2 gram butter and you have 12.5 milliequivalent of KOH. But as we see, after this reaction is complete, still some KOH is left, right? That's why we need HCl, right? So how much HCl is required? We need 8 ml of 0.5 NHCl. So we need 8 ml of 0.5 NHCl, right? So let's using this particular data, let's calculate number of milliequivalent of HCl. That is again volume in ml into normality, which is 8 into 0.5. That is nothing but 4 milliequivalent, right? So assume that we have 12.5 milliequivalent, but out of that, X milliequivalent was not consumed, right? Okay. So in that case, we can say that 12.5 minus X milliequivalent reacted with this 2 gram of butter, right? And what about this X milliequivalent? This X milliequivalent was consumed while reacting with this 8 ml of 0.5 N HCl, right? So this is what KOH, and here it is what HCl. Again, the product will form. And we have X milliequivalent of KOH, which was remained, right? When this KOH reacted with butter, right? And HCl is basically what we have 4 milliequivalent. And we know using law of chemical equivalence, for 4 milliequivalent of HCl, or probably for X milliequivalent of KOH, X milliequivalent of HCl will be required, which is 4 milliequivalent. So X will be nothing but 4 milliequivalent. So 4 milliequivalent KOH was unreacted out of this 12.5 milliequivalent while reacting with this 2 gram of butter. Now this 4 milliequivalent was consumed or was neutralized by this 4 milliequivalent of what? HCl. Okay. So here the KOH which reacted with the butter is basically 12.5 minus 4 milliequivalent, which is nothing but 8.5 milliequivalent. So 8.5 milliequivalent of KOH reacted with this butter. What about if we have to convert this milliequivalent into mass? So we know, we have to multiply it with what? Equivalent mass. And equivalent mass for KOH was basically 56 gram. We have already calculated that. So 8.5 milliequivalent into 56 gram per equivalent, right? So that will give you 8.5. Let's calculate it. So it will be 2. It is 17. And this 2, this is what? 28. So this will come in what? Milligram. And it's 28. Let's write it like this: 30 minus 2. So it will be 510 minus 34. That is 476 milligram of KOH. So if you see 476 milligram, 476 milligram of KOH reacted with 2 gram of butter. So for 2 gram of butter, basically we need 476 milligram of KOH. So for 1 gram of butter, we need half of this, which is nothing but 238. 476 by 2, simple unitary method, 238 milligram of KOH. Now let's read the first line. What is saponification number of a fat or oil is defined as the number of milligrams of KOH required to saponify 1 gram of fat or oil. So 1 gram of butter, which is fat or oil, we need what? 238 milligram of KOH, and that will be the saponification number of that particular sample of butter. So saponification number for the sample of butter will be 238 milligram of KOH per gram of sample. I hope you understood this concept. Thank you.